The latest nutrition fads promote the health benefits of a gluten-free diet. However, we seem to know little about this substance and whether there is actually any advantage in being gluten conscious. In the following presentation, we will evaluate relevant research and whether any political action should be taken in the state of Texas to confront this issue. Gluten is a protein composite found in wheat. It consists of two protein fractions called gliadin and glutenin. Gliadin is considered the culprit in inducing immunologic reactions because it resists breakdown by intestinal enzymes and cannot be well digested in humans. Gluten is found in many everyday products and therefore poses a major risk for susceptible individuals. It is used in most wheat-based baked goods and is common in bread and cereals. Other food items may not have wheat, barley, or rye on the label, yet they still contain gluten. For example, some beers are made with malt, a type of barley. Gluten is everywhere. Many foods and even non-food items contain gluten, including breads, cereals, teas, coffee, condiments, spices, meats and poultry, vitamins and minerals, prescriptions and over-the-counter medications, lipsticks, toothpaste, mouthwash, adhesive on envelopes and stamps, and even arts and craft supplies. Human exposure to gluten likely began during the first agricultural revolution. Egyptian farmers were major cultivators of wheat, and it is likely that this grain moved with them. Over time, farmers began selecting wheat varieties that yielded higher produce and better dough-forming flours, which were those with higher gluten content. Gluten was initially discarded after processing. However, in the early 1930s, bakers in New Zealand and Australia discovered that gluten could be utilized to enrich and improve the quality of their bread loaves. And by 1938, they had developed industrial processes to produce and flash dry gluten at a commercial sale. Today, wheat is the second largest crop annually produced and consumed. Due to its low production costs and advantageous chemical properties, gluten has been incorporated into many foods since the 1960s. In fact, consumption of vital dry gluten has roughly increased by over 200% since 1977. Gluten is also used as a meat substitute in vegetarian dishes. Using extrusion technology, food manufacturers have been able to texturize wheat gluten to mimic the chew, feel, and even taste of meat. These methods are now frequently used for ready-to-eat entrees, sandwich fillings, and even the meat-like structure of the veggie burger. Over the past several decades, consumer demand for convenient, ready-to-eat meals has increased greatly, causing changes in production. Gluten has supported the increasing popularity by improving their texture as well as their protein and water content. In fact, gluten is present in nearly 99% of frozen meals and pizzas.
Here is a kernel of wheat, and gluten is in the endosperm. Gluten is a storage protein that helps store starch.
When wheat and related grains are consumed in the mouth, the starch portion is broken down but not gluten.
Gluten, being a protein, is first broken down into smaller segments in the stomach, then further digested into the smallest unit in the small intestine.
As a recap, gluten is consisted of gliadin and glutenin. Research has found that the gliadin component contains difficult to digest parts, and undigested parts are found floating in the small intestine. Now let's take a closer look at the small intestine. Here is a dissection so you can see the inside of the small intestine called the lumen. The surface of the intestine is filled with these finger-like protrusions called villi.
Here's the picture of one villus. Each villus is lined with thin epithelial cells that allows nutrients to be absorbed into the bloodstream, and you can see the blood vessels in the picture. Here is the surface of a villus. Digested nutrients are small enough to travel through the thin wall of the cells to get into the blood vessels. However, undigested gluten parts such as gliadin are too big to go through and are excreted. In people with celiac disease, gliadin stimulates opening of the gates called tight junctions, allowing gliadin to travel through the cells of the intestine and enter the bloodstream. Undigested protein segments like gliadin should not be present in the blood. It is tagged by antibodies as invaders, and therefore triggers an immune and inflammatory effect. The above mechanism of gluten sensitivity is clearly demonstrated in celiac disease, However, gluten is also clearly linked with type 1 diabetes, a skin disorder called dermatitis herpetiformis, gluten ataxia, and most importantly, non-celiac gluten sensitivity.
Non-celiac gluten sensitivity is a group of conditions caused by gluten, but without evidence of celiac disease and allergy to wheat. It is difficult to estimate prevalence of NCGS because doctors don't usually associate these symptoms with gluten sensitivity, and this syndrome can be underdiagnosed.
Celiac affects around 1% of the U.S. population. Testing and diagnosis involve detection of antibodies in the blood or intestinal biopsy with atrophy. Among the working population of Texas, this translates to around 70,000 to 100,000 cases. Symptom severity ranges from asymptomatic to debilitating, and research suggests that 80% or more of cases may be undiagnosed. Estimates of non-celiac gluten sensitivity are even higher. NCGS affects up to an additional 6% of the population, and there are no laboratory tests available for diagnosis. Instead, NCGS is diagnosed by exclusion. Many patients self-identify illness by implementing a gluten-free lifestyle. Both celiac and NCGS may affect worker productivity, especially if the condition remains undiagnosed and the worker continues to trigger symptoms by consuming gluten. Texas is growing and the prevalence of celiac may be rising too. Increases in symptom awareness are leading to improved recognition and diagnosis. At the same time, a recent study in Minnesota suggested that celiac is now 4 times more prevalent than it was 50 years ago. We do not know what is causing these changes, but we know they are expensive. In the Mediterranean, an area with similar rates to the U.S., medical costs related to celiac are estimated to total $5.5 trillion over the next 10 years. And this is only for celiac. The numbers for NCGS may be similar, but the caseload appears to be much larger. In both diseases, medical costs aren't the only loss. Time spent ill and absent or distracted at work also affect productivity. Early diagnosis appears to be a significant cost saver. One study found savings of $4,000 to $10,000 over 4 years in confirmed versus undiagnosed celiac cases. Based on the current low rates of identification, however, it is likely that gluten-related illnesses impose significant economic costs on Texans and local businesses. We believe that Texas must act to address the burden of gluten-related illness. While statewide screening is not economically feasible, increased awareness of celiac and NCGS may maximize worker health while minimizing taxpayer costs. Systematic reviews have supported the value of work-based health education interventions. Therefore, we propose a pilot test or randomized controlled trial of a theory-based gluten educational intervention in a sample of 500 to 5,000 person companies in Central Texas. Employee variables of interest include gluten-related knowledge, screening, gluten-free diet adherence, self-reported health, medical costs, absenteeism, and presenteeism. Companies will be randomized to a control condition or an email-based educational campaign. Information will include known risk factors, signs and symptoms, benefits of screening and management, and resources, including local care and publicly available information. And changes will be assessed via a validated health assessment questionnaire as well as company records. Pre- and post-intervention assessments will be completed by each group. Study limitations include a lack of confirmed disease status and possible overestimation of risk. If inappropriate, testing in gluten-free living may not improve worker health or costs. History testing and contamination also threaten validity, as increased knowledge of gluten-related illness among controls may decrease program effect size. Finally, external generalizability may be limited based on the piloted employees and companies. Still, this study will fill a critical knowledge gap. If successful, it may provide a low-cost, highly effective method for Texas to address the personal and economic burdens associated with gluten-related illness in the workforce. Thank you for your consideration.